Now, having understood the modulation and the demodulation and appreciating the fact that just by adding a DC, I can do the demodulation with a diode and a low pass filter, which can be an R and C. Now we need to understand the importance of the DC. Now, when you add DC, a rectifier always removes the negative part. So that means I need to push my signal higher up. So the more DC you apply, the more signal will be pushed up. So the more signal is pushed up, the more it will be recovered after the diode. Now if you give too much of DC, the problem would be your AM double sideband signal will have a very high DC value, and this very high DC value will mean you need lots of power. So there is a trade-off between how much DC to be added, because if you add less, you lose your signal. If you add more, you need more power. And if you just add exactly, so for example, for the perfect scenario, is when DC is equal to minimum of my message signal. The minimum of my message, just take the negative of it because I want to push it up. So the minimum value of your message signal, I will add it as a DC so that it will be pushed up. So you don't need a minus, right? Just add it. So whatever is the minimum part of your DC, yeah, there's a minus, sorry, there's a minus because you want to push it up. So if your signal is like this and this is your minimum, say -5, so what you're going to do is you will just, this is your message signal MT, so what you will do is you will do MT plus 5. So if you do MT plus 5, then the whole signal is shifted up and it starts from 0. So there is no negative part. Thus, when you come to the rectifier diode, you will get the whole signal positive part. The negative part is removed. So none of your good signal is removed. Okay, that's the importance of the DC. And based on the DC that you add, you can have overmodulated, undermodulated, and obviously perfectly modulated. All right. Okay, and this is something that you will have to explore because screenshots are there on your lab manual, and please have to explore. So that's the AM double sideband. Now, having understood this, we will look at AM double sideband suppressed carrier, and having understood them theoretically, mathematically, in frequency domain, time domain, we will just go and do it in the hardware part. Okay, thank you.